So that big barrel right there is like your dryer at home. So it rotates this way, and if you look behind me up here, you'll see the rods. They're about 3.5 inches in diameter, and they're about 9–10 feet long. These two were a consumable that were delivered behind me back here, and they would have to add these periodically throughout their shift. What happens is it comes over, it's all automated, and it drops them in to that barrel. Inside that barrel, they're pulling material out of that hopper that you guys just walked by, and they're bringing that into this barrel as well. So remember, that stuff was kind of like road gravel. It's 1/2 inch or 3/4 inch minus. It's coming in here. As this thing turns, it's adding more water to it, and it's a slurry. And the smaller particles, there's a grate in there that's going to grate it, and it's going to be allowed to come down to this hopper below me. So at that point, in here, this stuff should be about the size of sand. That's how this comes out. So it goes from about 3/4 inch down to sand in this rolling, tumbling action. What this Archimedes screw does is it's going to pull that slurry uphill to the next process. As it does so, anything that's still too big that might have escaped through there comes back down, and it'll continue to get crushed until it's small enough to make it all the way up to the next process to go through. So if you'll push the button over there, you'll see this screw turn, if it's on.
I don't think it's on.
No?
Oh, dang.
Did
you push it hard?
Push the button and the screw will rotate. It doesn't go very fast. I mean, it's pretty slow. So if you guys make your way back out, we're going to go down, and I'll stop you. I'll see if I can get to the front again and figure out where we're at.
The Tesla motor.
So this motor, it's a Tesla design and built by Tesla, one of 3 built.
By Nikolai Tesla, not by the modern thing.
No, and it's the only one in existence. And the plaque will capture that data probably the best for you. What they're using it for is to power the ball mill.
Oh, okay.
Take a good look at it now.
Now, the mill's up on the mountain. Depends on how high that they had to get them up there. Of course, the smaller diameter, it's going to weigh less. They can come up easier up onto different mountaintops for processing. Down lower, you'll start seeing bigger and bigger sized stamps. But the way the stamps mills are designated is just by their count, rather than the diameter of them.
Scott, this sign says that the average stamp is 850 to 1,000 pounds. So imagine a 100 stamp mill with 100 stamps, 850 to 1,000 pounds.
And that's what it takes to crush up this rock in this area. It's extremely hard. The next piece over is one of the original flotation devices. We'll talk more about flotation when we get down here into the room, but this is what one of the original ones looked like to do the flotation process. So that's what's kind of here's more history than what was being used in the building itself. So it's what we call 100 minus typically. So if you take a screen door, and if you could take a 1-inch section of that screen door and you count the numbers of holes, 100 holes in 1 inch is what they call 100 minus. Minus meaning material will go through it. Anything bigger than that stayed in that hopper until it got small enough to come out at 100 minus, talcum powder fine. At that point, the rock is starting to release all of the different metals that are bound up in it that are what we call free metals at that point. So the next process it would go through is right next door here, and that's called a jig. What a jig does is that slurry, everything's still all wet, it's mucky, it's cement, now it's 100 minus, so it's real pasty, like, you know, toothpaste almost, that comes out and real gritty. What it does, it goes into that jig, and that jig pumps up and down, and it's got a set of rubber bellows inside it. And with that, we talked earlier about specific gravity. Remember, water's the norm. Gold is 19.3 is its specific gravity. It's 19.3 times heavier than water of the same volume. Lead is 11.3. Silver, 10.5, copper, 8.8, and zinc is 7. The country rock, the granite and the other elements that are up here in the mountains, that all weighs less than this stuff. So as that jig pumps, it was kind of like when I had the pan and I was shaking it, gravity's pulling those heavier items to the bottom. So gold being 19 times heavier than the water, works its way all the way to the very bottom. And then the next layer up would be lead, silver, copper, zinc, and then the leftovers at that point. So this slurry is getting shaken like this, and it will filter off the bottom of it every so often that's got the gold. That gold is what we call a free gold at that point. It looks like gold, it's real gold that you can see, it's very, very small, it's talcum powder small. And that would get shuttled off into a room behind you over here and get processed out right then, right there. The rest of the slurry continues on down the process, which will go to the next room in. As it foams up, you can look at the remnants in here. You can kind of see what that foam would look like. It's just kind of this gray sludge and it's all bubbly. And as it foams up, it's going to come off the top of this little spillway and go down. It's going to go down to the next room for processing. So at the very front end up here, the first thing that's going to get processed off, the gold has already dropped out for the most part. There are still some golds locked up in this material that's going to continue through the process, but the bulk of the gold has been pulled off in the jig. So there is some gold that's going to get pulled off first. Everything is gravity based. The next set of hoppers in here, the lead is going to get pulled out because it's got the next highest specific gravity. And they're adding different chemical elements to this slurry to make the froth. It will rise up the metal that they want, and it will suppress or let the other sink into the next process. And then they'll add another chemical, foam that one up, and pull off the next metal and send it downstairs for processing. Now what you're going to notice in here, from where we just came down that last little set of stairs, from this point forward, they start getting more secure. The grates are here mostly because we got to be elevated, but as we make the corner and come downstairs, you're getting, the general labor was up here, and you're going to get fewer and fewer people working, which is because we're starting to get valuable metals pulled off. This is probably a good point to talk. In a shift here in the late 90s when this was running, and it was running efficiently with all of this current modern technology, if you will, in here. Night shift was the production shift. Day shift was production with maintenance. Night shift, how many people worked in this building? Think about it. Think about how big this building is.
100.
8. 8 people would run this overnight.
Wow.
There was a foreman, and there's a guy at each of those different crushing stations that monitored it, and there's kind of a runner that would go around and fill in where needed. 8 people could run this facility. So it's very, very efficient, very, very automated as it got developed into this. Now initially, back in the day, probably in the 20s, I don't have the numbers, but I would venture a guess it was probably more like 40 or 50 people in here doing the maintenance and stuff, night and day, because things weren't as reliable as they are with the automation process.
Scott, the chemicals they're using, nitric acid, what else?
There's sulfuric acid, nitric acid, there's arsenic. In addition to that, there's some oil-based products that they're using as emulsifiers. If you guys have seen a drop of water, when it just sits on like your car hood or on a leaf, it's got what they call surface tension. That's why it stays in that bubble shape. If you add dish detergent, like Dawn, to it, it flattens out real quick. You break that surface tension. At different points, that's what they're doing, is they're adding different elements in here to break that surface tension and let the other metals settle, but the elements that they're adding are floating the desired metal off, and it's based on specific gravity.
Where'd they dispose of the water?
That's exactly.
A lot of it was reclaimed, meaning it was filtered out and brought back in. Some of it would continue on, because to move this slurry through the process, they've got to get it all the way out there onto that field. So very little of it was really screened off here. Here in the mountains, you see there's kind of an endless supply of water that because they don't have to it's not purified, it's not really anything special. They're just going to take the heavy debris out of it, and they're going to run this slurry through with it. And then they're going to put it out to the tailings field. This mine was one of the inventors of the tailings settling ponds. This was the first place that those were done in 1929. What they did is they ran it out here, this slurry, they would pump it up into a settling pond, just a retaining basin, let the heavies settle out, the sediment settle out, and the water would continue on. Before that point in time, all these other mills, those 100 stamp mills and these other mills, everything that came out went into the Animas River, which is why the Animas River is the color it is on the banks today, is because all of those metals, like the arsenic that was in the cyanide that was in here, just went straight out into that river. And Dwayne, I'm
No
sure
fish in that.
he did touch, what was the big spill? The EPA went up to a mine here in Silverton, and it had been closed off, and these are the experts for the EPA that came in. And they went in to deal with this, and they opened it up, and all of a sudden, all hell broke loose. And it dumped out into the Animas, and it polluted everything on down.
Well, that's in your handout, it was actually up Cement Creek.
Yeah.
Okay.
Okay.
If you read through your handouts, I got a
That's
good
where-
story on that.
All right, so what we'll do, we'll continue on to that. These, they were probably running around a 95% extraction rate,
Compared to 60.
60 earlier.
How much gold a day on average would they get out of this?
I think it's down in the next room, we'll take a look, but I believe the gold processing in here, one-day process, and again, it fluctuated, it depended
Sure.
on how high of a grade ore they were able to bring through, but they're probably processing out of here something like, I'll do it in pounds rather than ounces.
Yeah.
They're probably producing somewhere between 40 and 60 pounds
Of gold?
of gold
Really?
in a shift
Ooh.
out of, in a day out of here. But they're moving a lot of rock through
Yeah.
here as well. Remember, 5% of that rock that came in is going to be down below us. 95% of it's headed out to the tailings pile out there. Down below us, as you came down those stairs, there's lead and zinc holding tanks because that's the first two elements that would be pulled out of that slurry and just pumped down to those holding tanks, which really was a bulk of the fine metals that they're going to pull out of here, there was more of that per volume than anything else that was processed. There's less gold, there's less silver by weight, or volume, than those other metals being pulled out. Behind me is it's an assay room or a sample room. What they would do is they would pull samples out of here, and if you look in these holding bins here, they would pressurize these and test them. You'll see one that says tailings, so they're going to sample the tailings and see what's still left in it to see their efficiency, see what they need to make adjustments to. There's a zinc, which is ZN, PB is lead, and then I'm not sure what the first one here, it's probably copper would be my next guess on here. And what they're doing is they're just seeing how pure it is that it's coming out and the volume of it. Most of those raw metals of everything but gold is going to leave this still in a unprocessed, completed state. It's very concentrated, and they would send it on down to Durango or into New Mexico for final processing to finalize the zinc, to finalize the lead, to finalize the copper. It was just a very concentrated slurry that they would transport out of here. The gold, on the other hand, most of it was the free gold that's going to come out of that jig, and it's going to come underneath us, and we're going to make our way over into this next room because that's all happening simultaneously with this. Kind of above us is right here. This is that jig that walk by. So what it does is it brings the heavies down here, you drop into this trough, and then as the trough comes across here, it's got openings, and it starts letting this slurry, it's still kind of this cement muddy mess, but they're starting to add more clear water to it to process it. What happens is, as this goes down, these little BBs that you see on here, these are the remnants from the ball mill that have come through. So what they'll do, there's a series of little riffles, if you see them here on this table. This is called a Wilfley table. Wilfley was right here in Silverton, and he designed this table. Now, it was much smaller to start with. This is a commercial operation, so this is a giant Wilfley table. And if people's hands aren't on it, if somebody, you want to reach up, just push the button right behind you, you'll see this shape. That's what it does. So what it'll do, the water comes down, and you can make fine adjustments in here, and what will happen is, as this stuff starts processing, you will get a line of gold, because that's the heaviest item in here, and it just kind of runs along here, and it'll get caught in one trough. The rest of it goes on, and they're going to resend that back through flotation at that point. So everything kind of gets recirculated, and that's how they keep those recovery rates as high as they were in the upper 90th percentile. In the next room, there's a similar table, but it's two-sided, and I can't pronounce it. It's a Deister, I think, or Deester table.
This is the,
This should be a Wilfley table. The Deester table should be a two-sided one that's in the next room. Does it say something different over there?
This is a D-string.
It does.
this is a Deester.
That's what a Wilfley table looks like. Growing up, my dad had one. He called this a Wilfley table. So maybe there's
they're wrong.
tomato or something. I don't know. But the next table does the exact same thing, but it's going to allow it to refine it even more and clean out all the other metals. Like Bruce was talking, if you saw when we panned, you probably didn't get a real good chance to see that. But if you take a whole scoop out of a stream and put it in your pan and you pan it down, you got what we call the blondes. Everything that's a light colored rock goes to the top. It's a lightweight, you can get rid of it. And you want to get down to what we call the black sands. The black sands are hematite, magnetite, your lead, your silver, your zinc, those other heavy metals are all mixed into it. So when it gets to this point, it is truly more of a black sand. Everything else that's light is still upstairs going through this. There might be a little bit in here, but this table will process that off real quick and get rid of those other items. The hematite and the magnetite. Magnetite's really easy to deal with. There's magnets in some of these different places, and it's just a revolving magnet, and it picks it up on a screen, if you will. And as the magnet goes away, then it falls off, the magnetite does. And they'll pull these little metal balls, they'll stick right to that magnet, and they'll get pulled off. And you can get rid of that overburden, as we call it, because it really doesn't have a value. It's just a nuisance and it's in your way. But the magnet is a quick way to reduce your work by about 50%. The hematite is non-magnetic. It's a black sand that you just have to deal with. And that's where this table works very efficiently, really, really fast. It's just magic to watch it happen. And the next room is it's the same exact thing occurring, but it's just another refinement process to clean it a little bit further. And then the next thing they're going to do is they're going to take that flour gold, all of those little particles that they've collected of gold out of this and the other room, and they're going to melt them into a bar. Some of that slurry that's going through up here it's got the sulfide golds. They're going to use chemicals to basically dissolve that out, and they're going to recapture it. One of the ways initially that they were recapturing it is, and the stamp mills work this way for years, is once the material would go through those stamp mills and come down, and it's this slurry, then they had a copper sheet. They'd have a sheet of copper as wide as this and as long as this, pitched at an angle. And what they would do is they take mercury, liquid mercury. Mercury at normal room temperature, being a liquid, it has an affinity for two things. One is copper and the other is gold. It sticks to copper, so what they would do is they just use a big squeegee and they put a ball of mercury on there and they squeegee it onto that copper plate. Now that copper plate is silver looking because that mercury is stuck to it. And what they do is they run the slurry over the top of that, and gold will fall out of that real quick because of gravity, but it sticks in the mercury like it's glue. And the rest of it will wash off because the mercury doesn't have that affinity for the other metals. And then at the end of the shift, what they would do is they take that same squeegee and they squeegee off the mercury back off that copper plate. And they condense it. In the small scale mining, what you would do is you would take a chamois, like you would wash your car with, leather chamois. You put the mercury in there with the gold mixed in. Now it's called amalgam. And what you do is you squeeze that chamois out. The mercury will go through because it's a liquid, and it will come through that chamois. It's a filter, if you will. And you're left with this little gooey, sandy particle in the bottom. And that's mercury-coated gold at that point. It's all those little particles of gold with mercury wrapped around them, and they stick together and they just make this little ball that they call a sponge. What they would do then, and there is a room in here, I'm not sure exactly where it is, I'll have to see if I can come around the corner and pick that out. But what they would do in the early days, before they figured out mercury was real dangerous, you just build a fire under it, and you boil off the mercury, you vaporize it, and it goes into the air, and you're left with gold. When they learned how dangerous it was, the better way to process it is through what they call a mercury retort. What a retort is it's a still. You take this ball of mercury, and in an operation like this, I mean it's a big ball, and they may break it up. But a small scale mine, you can take a piece of steel pipe with a cap that screws on, and you put that mercury in that cap, and you screw it on, and then the tube is here, and then it goes through a series of coils in water, and then it comes out the other end, and there's a glass jar on the other end of it. You heat this end, and it boils off that mercury. Mercury vaporizes, goes up the tube, goes through the coils as a vapor, and it cools back to a liquid, and it comes out the other end, and it's captured in the jar. Once it goes from vapor to liquid, it's safe to handle to a point. Again, So they're capturing it, and then they're gonna go smear that back on that copper plate because it's clean mercury. In the bottom over here, when you unscrew that cup after heating it, you've got a button of gold. And it's now captured and it's clean. They would use, for several years in here, there is a mercury retort. They did use mercury in this facility. And they would clean it and run it through a mercury retort to capture the mercury and put it back onto those plates to do capturing. And that's not here, because this is free gold. That's in the, as the slurry would go through, and that's one of the final capture things, is kind of a last resort to get what they could out of it. And then they would clean those out. Normally, in most mill operations like this, I would doubt that they clean, like this where the gold comes off, at the end of a shift, before the next shift comes on, they'll clean out what they've processed. And then the next shift has basically a clean table to start with, and they'll run it for their shift. And it would just cycle like that through most of these. The flotation process was always kind of up and going until they needed to clean it out, and because it became chemically unstable at that point. As you make your way around, you'll see the gold processing room. As you notice in here, see the security around this room? This was enclosed. Only the higher end employee or employees would be allowed down here because this is where the money is. The rest of the workers could not get down into this, so that is the security. We also talked about hydrating. My dad worked in many of these mines up here, and every one of these miners, if you ask them, if they got into a real good pocket of gold or producing stuff, chances are it was in their pants pocket or in their shirt cuff, in their lunchbox. They'd take some out. I know my dad did. I have some of it, and some ore samples that have just remained with us. Somebody asked, well, how would you process that? I can tell you, as a small-scale miner like myself in California, I go out, or I'm up here in the mountains, I go through a tailing pile, and I'll find some really nice samples of rocks that I want to sample. I've got a crusher myself. It's just a steel tube about this big around. It's got a metal bar inside it like a stamp mill. It's a single one, and it's got a T-handle on it. I put 4 or 5 rocks like the size of my hand in there, and you smash them. You smash them. And you smash them. And once you're done smashing it, then I take it over and I'll pan it out. Because I make it talcum powder fine, and I can pan that stuff out, and I can see if I was in a good spot or not in a good spot. Same exact thing that these local miners did. Somebody asked, well, how do you sell it? The same way I sell it today. The big companies, they produce a gold bar. It's very clean, and they have a buyer for it, or a series of buyers, whoever will pay them the most money for it. What I would do, I hoard my gold, so everything I find I keep. I don't sell it, but there are some that do. You can go any of these gold stores that you see at the malls or in those little strip malls or wherever we buy gold. They will buy your free gold that's in a vial, and they'll look at it. They'll basically spot assay it and tell you, yeah, that looks like it's pretty pure. Gold today is $12.50. I'll give you $1,100 an ounce for it, and that's how they're going to make their money, is that difference, because they're going to send it off and purify it, and they get their money that way. The same exact thing occurred 100 years ago. The miners up here in the mountains, they would process it. The placer miners, they're getting real clean gold to start with. The hard rock miners, that are the little mom and pop operations, they're having to crush it themselves, process it themselves, or they would sell it, they would take it down and have it assayed, and then they would sell a ton of rock to like this company and say, hey, it assays out at this many ounces per ton of these elements, and they would buy it and they would finish processing. If the small scale miner would process it themselves, they could go to the grocery store and buy their staples, their milk, their eggs, their steak, and they would pay for it in gold dust. They'd go to the saloons. They would play poker. Many store owners made more money on what they pulled up out of the floor from the dust and the remnants than they ever did selling anything. There are places in California, some of these old areas that are now abandoned, and they're moving the building off. People go in and shovel up the dust underneath the floor, and they'll process it out, and there's just ounces of gold in the dust on the floor because these drunk miners pull it out of their poke and, you know, 3 or 4, you know, a bunch of it spills on the floor and they make it over to whoever they're paying off, and it just stays there. So there is a market even today for small scale mining to sell as little or as much as you want.
Where do you live, Scott?